Happy Tuesday, geometry. This video is about the segments intersecting inside of a circle. This is day 10 notes on special segments. So here goes. For starters, anytime you have two segments that intersect inside of a circle, you'll have four different segments. Okay, we took one segment here, but now we have an intersecting point. And now we have this segment and its counterpart, as well as this segment and its counterpart. Okay. Now, the equation for this is, how do we figure how long these things are? Well, this first half of the original segment and its second half, and then this first half and its second half. We can multiply each half and set them equal to the opposite chord. So if I take A times B, it must equal C times D. Okay? Make sure it's the same chord here. If I take the first portion of this chord and I multiply it by the second portion of the same chord, I can set it equal to the first portion of this chord times its second portion of that chord. Okay? And that will give me the length. Those two items must be equal to each other. The products of the individual segments must equal the other chord. All right. So for starters, we have problem number one says that there are these two chords here. And then it says this portion is 2, and this portion is x, this portion is 3, and this portion is 6. So we must be able to say that 2 times x must be equal to 3 times 6. 2 times x must equal 3 times 6. We know 3 times 6 is 18. So 2x is equal to 18. Divide by 2, and x is equal to 9. All right. We can take that one step further, and we could say that the entire length of this chord must be equal to 11, right? Because this portion plus that portion would equal 11. Number 2 says that we have this right here and this right here, and then we know that this is a diameter. We have an intersection of 90 degrees here. It says x here and x here. Then it says a 2 in this little portion right here, and then a 10 for this radius. Now, what information can we gather from that? Well, we know that this entire other portion must also be 10, but we need to know what this portion is. So if this is 2 and this entire portion is 10, then that means this piece right here is 8, which makes this whole thing 18. Remember, we're having to multiply each side of the intersecting point here. So this is going to be 2 times 18 is equal to x times x, or x squared. So 2 times 18 is 36, and that is equal to x squared. We can do the square root of both sides and find that x is equal to 6. So each piece must be equal to 6. Or if they ask what is the entire length of this chord, we could say 12. Okay? Number 3 here says, let's see if, can you see that entire circle? No. Number 3 here says it has a chord here and here, and then this portion is 2x, this portion is 3x, this portion is 5, and this portion is 6. So we take each section and multiply it by its paired section, so 2x times 3x, and that must be equal to 6 times 5. So 6x squared must be equal to 30. Divide both sides by 6, and I'll get x squared is equal to 5. Do the square root of both sides, and I will find out that x is equal to the square root of 5, or approximately 2.2. Okay? All right. Number 4 is a little bit more complex. I'm going to need some extra writing room here. Number 4 says that we have a circle with a chord here and a chord here. It says this chord is x plus 1 and x plus 8. This is x and this is x plus 10. So we're going to take x plus 1 times x plus 8. X plus 1 times x plus 8 is equal to x times x plus 10. Now we get to distribute or FOIL. And we're going to do x squared plus 8x plus x plus 8 is equal to x squared plus 10x. All right, combine these like terms and I get x squared plus 9x plus 8 is equal to x squared plus 10x. This is great because now I can get rid of my x squareds on both sides. Subtract x squared, doesn't matter which one, we have the same. These two cancel each other out. Now I get 9x plus 8 is equal to 10x. I'm going to move over my 9x because you always move the smallest one. And now I get x is equal to 8. Simple. All right. Number 5 says Sierra has this cake. Thanks for making cake, Sierra. I guess you didn't get the Pi Day memo, but whatever. Cake here. All right. And then it says, let's see, Sarah serving cake at party if the dimensions of the remaining cake are shown below. All right. It says that we have this whole thing is 9, and this portion is x, and then we have 6 and 6. So 9 times x, or 9x, must be equal to 6 times 6, or 36. Divide by 9 on both sides, and I get x is equal to 4. Now, it says, what is the original diameter of the cake? Well, this portion is 9, this portion is 4. So now my diameter is 13. And I think it's all in inches, so inches. All right, number 6. That was number 5. That was number 4. This is number 6. It says this right here. Find the radius of the circle. Okay, we can do that. So we got that going on, and it says this whole thing here is going to be x. Great. And then it says this portion right here is 2, and each of these are 4. All right, so we do 4 times 4. 4 times 4, and we do 2 times x, and we get 16 is equal to 2x, or x is equal to 8. But we don't stop there. Now we know that this is 8. So we know that the diameter, because we know this is a diameter because it goes through the center, we know that the diameter is 10, which means the radius must equal 5. Okay? All right. Let's see. Okay, I'm going to pause and set up the next. All right, so before we had the hat rule, right? Whenever we have two tangents intersecting the outside of a circle, we could say that AB was equal to AC. We said that these two things were congruent to one another, right? So now what if we have segments intersecting outside of a circle that aren't just tangents? What if we have two secants? And these are secants because they intersect twice. Or what if we have one tangent and a secant, okay? Well, we still have a ratio, and it still works off of multiplication, and here's how it's going to work. We take the whole secant, so AC, and multiply it by just the outside portion, AB. And we set that equal to the whole other secant, this whole AE, and it should be equal to AE times also the outside portion, AD. So AE times AD. You take the whole secant times the outside portion and set it equal to the other whole secant times the outside portion. Okay? Those two must be equal to one another. So that's what we're going to be doing throughout this segment. And I'm going to have to make another video of the practice problems. And there's one more. What if it's a tangent and a secant? Well, it's still going to be that whole times the outside and whole times the outside. And here's how that works. If we have the whole secant times just the outside portion, that would be Jm times Jl. And we would set that to the whole tangent times just the outside portion. So Jk times Jk, or Jk squared. Okay? It's still whole times the outside equal to whole times the outside. It's just that the outside and the whole are the same on the tangents. Okay? Whole times the outside is equal to whole times the outside. Let me see how many I can get done in the next 3 minutes, 30 seconds. All right, so the first one has a tangent and a secant. So we're going to say that the whole 3.3 times the outside times 3.3 is equal to the whole, which is 2.2 plus x, times the outside, which is 2.2. I'm going to distribute, and I'm going to get, what's that, 10.89 is equal to 4.84 plus 2.2x. Now I'm going to subtract 4.84 on both sides, and I'm going to get 6.05 is equal to 2.2x divided by 2.2, and I'm going to get x is approximately equal to 2.8. Okay. Now, the next one, number 2, says the whole, which happens to be, what is that, 26 plus 16, which is 42, times the outside, which is 16, is equal to the whole, x plus 18, times the outside, 18. Distribute and solve. 42 times 16 is going to give me 672, is equal to 18x plus, was the 324. 324, subtract 324 on both sides, and I'm going to get 348, and then divide by 18, and I'll get x is equal to 19.3. Okay, let's keep going. We have the whole, which happens to be 8 plus 8, which is 16. We know that because it's two congruent lines. 16 times 8, whole times the outside, is equal to the whole, 2x plus 6 times the outside is 6. So distribute and solve. 16 times 8 is going to give me 128, is equal to 12x plus 36. Subtract 36 on both sides, and I will get 92 is equal to 12x divided by 12, and I will get 7.7 is equal to x. All right. Number 4, the whole times the outside, or 35 squared, which is 1225, and set that equal to the whole, which is x plus 21, times the outside, which is 21. So 1225 is equal to, is that 21x plus 441. Subtract 441 on both sides, and get 784 is equal to 21x divided by 21, and you will get 37.3 is equal to x. All right. Have fun doing the last two. On the last two, this is the radius, that's 15, so that's also 15, and then plus 5. Okay. Good luck.